Hey everybody, Mr. Covey here, and this is 11.5, and we're going to be talking about how to find the area of regular polygons. So a couple of things before we start. One important vocab you need to know is what an apothem is for a regular polygon. So that's the segment that joins the center to the midpoint of any side. So if I have a regular pentagon there, the apothem joins the center to the midpoint of any side. That right there is my apothem. Don't get your apothem confused with an opossum. They are different things, very different. An opossum is a little animal. An apothem is the segment of a regular polygon joining the center to the midpoint of any side. I know they're similar, so don't get those confused, please. A couple of facts about the apothem. Circle in your regular polygon. The apothem is the radius of that inscribed circle. So, first thing to note is it's the radius, of a circle inscribed in the polygon. Please note that it is perpendicular to the side. The second thing is that all apothems are therefore congruent because they are all radii of the same circle. Third thing, this only works for regular polygons. So if you see the word apothem, you should automatically know the shape you are talking about is a regular polygon. And the third thing is that not only is the apothem perpendicular to the side, but since it is from the center to the midpoint, it is the perpendicular bisector of any side. Okay, so that's an apothem. Another piece of vocab is a radius. So a radius joins the center to any vertex. So for instance, that would be a radius. It is a different length than the apothem. And the radius is also the radius of a circle that is circumscribed around the polygon. So if you draw a circle circumscribed around the polygon, the radius is the radius of that. The radius of your polygon is the radius of that circle. Final thing to note is that the radius bisects the angle of the polygon. So it divides the angle in half. Okay? Okay, if you could go to your formula sheet real quick. Using the same idea, we have a couple of formulas for area of an equilateral triangle and area of regular polygons in general. We already have a couple formulas for area of an equilateral triangle. You could do 1/2 base times height. Specifically for an equilateral triangle, you could do side squared root 3/4. We already have those. A new one you can do is 1/2 A times P. Okay, so this is a new formula for the area of an equilateral triangle. A is your apothem, and P is the perimeter of the shape. Okay, so again, your apothem length would be that, and your perimeter is the perimeter of the whole shape. That same formula works for regular polygons, and we don't have a lot of other options. So 1/2 apothem times perimeter will give us the area of any regular polygon. Again, please note the distinction between the radius and the apothem. That line is the apothem. That is the radius. The formula depends on the apothem, not the radius. All right, let's get into it and do some problems. So this says an octagon with an apothem of 4.8 centimeters. So our apothem is 4.8, and each side is 4 centimeters. And it's asking us for the area. So if it's talking about an apothem, I know I'm talking about a regular octagon. The apothem's 4.8. If each side is 4 centimeters, then the perimeter is 4 times 8, so it's 32. I have enough to use my formula. My area will be 1/2 apothem times perimeter. So it'll therefore be 76.8, talking area, so it's our units squared. Okay, let's take a look at one more example. A square with side 24 inches long and an apothem 12 inches long. Okay, my area will be 1/2 my apothem times my perimeter. Well, my perimeter, if each side's 24 and it's a square, will be 24 times 4, and that'll give me my area, 576 inches squared. Again, you could, of course, use base times height or side squared to find the area of this square, but since they tell you the apothem, it's much easier to use this formula, and since a square is a regular polygon, this 1/2 AP does work. Okay, so next problem here, we're trying to find the perimeter, the length of the apothem, and the area of each regular polygon. So this is a equilateral triangle. We're going to use our 1/2 AP. What they tell us there with that 8 is not the apothem, it is the radius. But luckily, this is an equilateral triangle, so I know that that angle is 30 degrees, that angle is 60 degrees. It's a 30, 60, 90 triangle. So if my hypotenuse is 8, my shorter leg will be 4, my longer leg will be 4√3. Okay, and therefore my perimeter will be 4√3, 4√3, that's 8√3. So 8√3. But then there's 3 sides, so times 3. That'll be my perimeter. My apothem's 8. 1/2 8 times 8√3 times 3 will give me my area. Calculate that out. My area will be 48√3 inches squared. Next one here, similar situation, except for this is a pentagon. They tell me the radius, not the apothem. I want to know the apothem. I need to be able to find one angle. If you remember how to find an interior angle in a regular polygon, you can do number of sides minus 2 times 180 divided by number of sides, and you'll get 108 for each angle in a regular pentagon. Therefore, that's half of it, so that's 54 degrees. And now I want to find my apothem to start. So I will say, use a little trig, sine of 54 equals a over 20. So my apothem ends up being 16.2 centimeters. And I still need to figure out this length so that I can figure out my perimeter. I can do trig again, or I can just do Pythagorean theorem. It's probably easier. Now that I know 2 sides, I solve that. I get that half of my side length is, half of my side length is 11.73. So each side's 23.46, and my perimeter is 5 times that. So it's 117.3. And then I'm ready to plug in. My area is 1/2 AP. And that gives me 950.13 centimeters squared for my total area. Okay, let's look at another example. This is a hexagon. Again, they tell me the radius. I need to know the apothem, and I also need to know my side length. Using our interior angle formula, we can calculate that each angle is 120 degrees. So then when I cut it in half, I got 60, 30. Don't need to use trig here. It's a 30, 60, 90 triangle. So if my hypotenuse is 25, my shorter side is 12.5, and my apothem is 12.5 root 3. So then each side is going to be 25. My perimeter is going to be 150. And now I'm ready to plug into my area formula. I got 1/2 AP. Calculate that out. I should get 937.5 root 3 centimeters squared for my area. Okay, this next one's similar. The only difference is they don't give me the picture. So I should draw a picture just to make sure I'm labeling everything right. They're asking me for the area. They tell me the apothem is 8 inches. So I already know A. All I need to find is the perimeter. So to find the perimeter, I remember again, to find an interior angle, I use my formula. N minus 2 times 180 over N. Each angle is 108. Might have remembered that from the other problem. So that is 72 degrees. And I want to find, 54. And I want to find X. So I can use a little trig. Tan of 54 equals 8 over X. X is going to equal 5.8. So then if each side's 5.8, if the X is 5.8, then each side is 11.6, and the perimeter is going to be 11.6 times 5, which is 58. Now I can jump over and plug everything into my formula. 1/2 AP, and I should get out 232 square inches for my area. Why don't you pause the video, go ahead and try this one on your own, unpause it, and check your answer, please. So I'll give you time to do that. Okay. The only thing that was a little different about this one is they didn't tell you the apothem or the radius. They instead told you the perimeter. So you already know that. You need to find the apothem. To do that, I said the perimeter is 6. There's 8 sides, so each side is 0.75 long. So then if I draw my little triangle here, that bottom part is half of 0.75, which is 0.375. I did my interior angle to figure out each angle's 135. So then that angle's half of that, 67.5. I had this right triangle. I needed to find my apothem. So I did my trig problem over here, found my apothem. Then I knew my perimeter, I knew my apothem, and I was ready to plug it into my formula. And that concludes 11.5.